Good evening and welcome to my laboratory. This is the circuit that I'll be discussing today, now. This is the LaserSaber Crossover circuit modified by GadgetMall to produce what GadgetMall has found to be a self-charging circuit. At least that's what we think. So I've gone ahead and built it and put in some variations of my own to see what's going on. I replaced the this little 100 picofarad capacitor with a small trimmer capacitor, and I settled on using a 2N1304 germanium transistor in place of the 2222. And I used the 2222 in place of the TIP or 2N3055 on the output, or the high voltage, high current side. I found that this gave me the best and cleanest spikes of a bunch of different transistors that I used. And the germanium germanium transistor produces the highest frequency and the most sensitivity. So we've also got some germanium diodes in there. And for this sort of self-charging demonstration, or not demonstration, but rather investigation, I'm using a white LED with a 22 ohm resistor in series there. And I've got two current viewing resistors in the circuit. One of them before the capacitor, so I can view the current from the battery. And then I've got another one that I can switch in and out as the current viewing resistor that takes into account the capacitor itself. Okay, and those I'm monitoring the voltage output on channel B of the oscilloscope here, and I'm monitoring the current right now across the voltage drop, i.e. the current, across this 1 ohm resistor here with the channel A of the scope. And all of the scope references go to this point right here. So depending on which resistor I'm monitoring, I have to flip the channel invert switch to get the correct polarity for the current. Alright, and let's see, got kind of a glare from the whiteout corrections. Whoops. Okay, got that. And then here's the actual circuit right here. I'm using a NIMH battery that I charge to 1.3 volts about in the automatic charger. That's the on-off switch. That's the first current viewing resistor. The second current viewing resistor and its bypass switch is right there. I've got the Simpson voltmeter hooked up, monitoring the voltage on the capacitor, and then I've got the 3 scope probes right now. I'm actually going to do a comparison between 2 oscilloscopes. So I've got 2 scopes monitoring the output voltage at the LED, and 1 scope monitoring the current across that current viewing resistor. And there's the glare off of the little trimmer capacitor. I took and mounted the trim cap and the 1 germanium diode right there on a little piece of circuit board material to give it a little bit more mechanical stability. Okay, so what I'm going to do now is I'm going to put the, I want to show that it is glowing. I put the LED in a ping pong ball to act as a diffuser, but it's kind of hard to see it glow when the overhead light's on, but it is indeed glowing. Okay, so now I'm going to put, let's see, I'm going to turn on this light and show that I have the 2 oscilloscopes now displaying the same signal. This is my venerable old HP 180, and then this is a little bit more modern Tektronix 2213, 60 megahertz dual channel oscilloscope of a different generation, a little bit newer than the technology involved in the HP 180. But I got to tell you, I've got both of these screens at the best sharpness that they can display, and the HP has got a better display. It's more pleasing to the eye, it's definitely sharper, and just looks better. Also, the HP has a much better way of handling delayed trigger and displaying expanded time base. This one can do it, but it's not as good. Anyhow, I'm glad that I have the oscilloscope. I thought that FedEx had lost it for a while, but there it is, and it's built in. And I also have the nice, also got the tri-field meter back, which is a handy thing for checking fields within its range. We're not going to use that now. And then there's the DP101 pulse generator. All of it stacked right back up into the stack. Okay, at any rate, now what I'm going to do is mount the camera in the tripod, so excuse me for a moment while we jiggle around like that. And now we got glare. Okay, glare out the wazoo. Like that. Turn off that. That's not too bad, I guess. Okay, what I'm going to do is vary the setting on that little trim capacitor, and we'll see what it does to the scope traces. Okay, so right now let me turn up the radical illumination a little bit. You see that all right? Okay, so the channel A baseline, the current baseline, is the bottom one, and there's where its baseline is right there. Turn that back on. Those little spikes are the current spikes, and those are being displayed at 50 millivolts per division, or rather 50 milliamps, since we're looking at a 1 ohm current viewing resistor. So there's about a 60 milliamp spike right there, but it's very, very short duration. Little current spike right there. Okay. And you can see what's going on there. When that spike happens, the voltage at the LED drops, which means the LED has turned on. Then it comes back up as whatever it is charges up, and then there's another spike when the LED turns on, and then it comes back up like this. Okay. I think that's what's happening. Actually, that spike might be the LED turning off, and then the LED turning on might happen somewhere in there. I'm going to expand that trace in a little bit to show you what's happening. But first, let me go to more frequency display there. So now I'm going to vary the setting on the capacitor. Right now it's at its minimum capacitance. Now we're going towards more and 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 more capacitance. That's the maximum capacitance, and now we're going less and 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 less back to the minimum on that little error variable. Okay, now we'll change to a time base where we can see the individual traces a little bit better. Right there. Minimum capacitance now. More and 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 less 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 back to minimum right there. Okay, so you can see that the frequency changes and the shape of that little recharge cycle changes too. Now let me see if I can get an expanded trace. There's a lot of jitter in here, so the expansion might not work. So let's see here. Okay. What I'm doing is taking this trace here, or that cycle, and trying to peel it off to show the fine details in it. And because there's so much jitter, it's really, really hard to see. But what's happening is there's this downward spike, and then there's a level off period that's absolutely level, and then after a short delay, there's the little ring there, sort of an inductive ring down. And the current trace looks like a little hump, just a little U-shaped hump in there. Alright, now I'm going to vary the capacitance again. More. Pushed it right off the screen. Let's see if I can get it back. There. That's maximum capacitance right there. And one thing that it really does at the maximum capacitance is it makes the circuit a lot more sensitive to outside influences, like that right there, as I'm just touching something on the circuit. Now we'll go to less and less capacitance, and that's the minimum capacitance there. So if I peel that off, you can see that the area that was affected was where that little ring down is, right? And also the top of that spike where it takes it right straight off the screen. Come back here. Alright, so less and less until that's the minimum. More and more. Less and less. So what's happening is that little portion right there is being swallowed up by whatever the capacitor is doing. So if I go to the most capacitance right here of that little trimmer, which is going to be about 100 picofarads or so, then that's what we get. And the current trace has moved a little and elongated there too. Alright. Okay. For what it's worth, that is scoping the LaserSaber GhostLight TK mystery circuit crossover run on nothing circuit. Thank you for watching. Oh, let's go over here. Take a look at that. I don't know, it's a nice oscilloscope, but it just does not compete with good old HP 180. Thank you for watching.